Right. Greetings to all the great hosts. Welcome to EduPlash Visual Academy. I'm going to be presenting a topic on functions and graphs under the subsection of what transformation of functions. Right. After this lesson, great hosts, you should be able to transform a function. Okay. Right. This is an important section coming from your lower grades, and it's highly examinable at this stage. So it's just a review class. It's not something new. We did this from grade 10 and 11. So I'm just trying to polish up and give you more information on this section so that we can polish you as you are getting closer and closer to your finals. Okay. Allow me to take you to the board so that we can quickly start with this section. Okay. Right. I'm going to be looking at transformation of functions. If you look at your lower grades, you were told you looked at different types of transformations. The first one was translation. You looked at reflections. You looked at enlargements. Okay, right. Those are the transformations that we're busy with in the lower grades. Right now, but you're specifically looking at transforming coordinates. But now I want us to look at how to transform a function. Okay, transformation of functions. Fine. Now, let's look at the topic, transformation. Transformation. Transformation of functions. Transforming functions. Okay. To transform is to, in this case, systematically change location. To systematically change a location. But in this case, I'll be basically looking at functions and how you can move or shift functions from one point to the other. Okay, right. I'm going to take you back to the vision. Right. If you look at your functions, all your functions, right. Now, I'm going to look at the basic functions that we know. When I'm saying basic functions, I'm talking about the mother graphs before any parameter comes and affect or transform the given function. I'll start with the first one. We looked at the first function, which was linear function. And a linear function in its basic formation, it would be just y equal to x. But at this stage, when you are viewing your transformed function, transform functions. Right. Now let's look at this. When a linear function is transformed, you now incorporate functions like parameters like a, q. There you go. That's a transformed linear function. Let's look at the next one, which is called a quadratic function. Quadratic function, in its basic form, it was just word. That was from the lower grades. But now we look at the quadratic expression in this format: a x minus a p all squared plus a q. Now you can see that the basic quadratic expression, which is y equal to x squared, is now incorporating three parameters, which is a, p, and q, and each and every parameter as it is going to be introduced to that, it's going to come with its own effect. We are going to look at the effects as soon as I'm done with this part. So I'm just reviewing the next one. Let's call it the, remember, the hyperbolic function. Now, a hyperbolic function in its basic form, it will be something like that. But when transformed, this can be presented in the form x all over x minus p. That's a hyperbolic function for you, right? Now, the next one, it is the exponential function. The basic or the mother graph for an exponential a function is given by y, but when transformed, this is y equal to a times b x a q, something like that. Then you also have a logarithmic function, log function in its basic form to log of x, but uh, when transformed, this would be y times b times log x minus p base b plus a q, something like that. Right. Now, geometric functions. Functions. With the trigonometric functions, you've got something like, you also have something like y equal to cos x in its basic form, y equal to tan x. Right, but when transformed, this will change to y equal to a sine bx minus a p plus a q. Then this will be y equal to a p plus a q. Then the last one will be y equal to tan x minus a p plus a q. Right. Now, if you look at this from basic form to transformed functions, you can see that there are parameters that are now being incorporated. Parameters are very, very important. They come with different effects, and you've discovered this from your lower grades. The effect of each and every function, the effects of these functions from the lower grades. Okay, so I'm just going to look at the effects, how these effects or how these parameters would affect your graph, how each parameter will affect the graph, right? Then from there, we'll make general conclusions, and we apply those conclusions to solve problems. Okay, right. I'll look at basic effects and the conclusions that we made in the lower grades. Okay, effects of parameters, effects of these parameters on functions in their graphs, on functions. Okay, effects of these parameters. Right. Now, the first one, we did that from grade 10, which was what? Q. What was the effect of your Q? Remember, we said Q shifts the graph or the function either upwards or so Q affects the graph in two ways. Either it will take the graph up or it will take it down. If Q is positive, the graph will go up. If Q is negative, the graph will go down. We did that in your lower grades, right? P shifts the graph either to the left or to the right. We did this in grade 11 when we were investigating. I will show you with yet another illustration as we go so that you can fully comprehend what we are talking about. Okay. A affects the graph in two ways. The first one, if A is a negative, it reflects the graph along the x-axis, right? Then also it narrows or stretches the graph out. It narrows or stretches the graph outward. Good. This is basically what we did in the lower grades. This is basically what we did in the lower grades. So I'm going to take you back to these things so that we make the same generalizations that we did in the lower grades. Then I'll now come to your functions. Right now, to comprehend or to understand how, to master how each and every parameter affects, I'll start with vertical shifting. Vertical shifting of a function. If I want to vertically shift a function, which parameter is responsible for that? Vertically, it means you're going either up or down. So it is Q, which is responsible for our vertical shifting of functions. Okay, right. Now, let's look at this. Let's look at this. How? So, I'm going to give you a quick illustration, then I'll make a generalization. For me to know how to transform a function, I'm going to look at how the graph behaves. I'm going to compare certain graphs, right? I'm going to draw the following functions on the same set of axes. Draw the following um, function, or draw the following function on the same set of axes. Okay, now look at this. Look at this. I'm going to draw these three graphs. First one, call it f of x, and f of x is just x squared. The second one is g of x, call it g of x, which is x squared plus a 1. Then h of x, which is given by x squared minus a1. If you look at this, I'm trying to compare three graphs, x squared plus 1, x squared minus 1. Now, if you look at the difference in these three graphs, it is the value of what? Q. Right. I want to see if I look at f of x, the difference between f of x and g of x is this one I've added 1. So I want to see what is going to happen to the graph if I add 1 to the function. Okay, right. Now, whatever discovered that we're going to come up with on this illustration applies to all the Q's in all the other functions that we looked at. Okay, so I'm going to look at this. Look at this. I'm going to work with a table of values. Let's look at this. X. Okay. X. There is minus 3, minus 2, minus 1, 0, 1, 2, 3. Okay, I'm going to be drawing a graph there. I'm trying to come up with a table of values. Then I'm going to draw a graph. From the graph, we are going to deduce some conclusions that are very, very pertinent or that are very important. Then we generalize them and we use them all the way. Okay, right. Now let's look at this. Let's look at this. Now, I've got my table of value like that. The first one, I'm going to look at f, and you can see that f is equal to x squared. So if f is equal to x squared, I'm going to take negative 3, the value of x, and plug it where there's x squared. Negative 3 all squared, you give you 9. Negative 2, plug it there, it becomes what? 4. Negative 1, put it where x squared is. In f, you get what? 1. 0, it's 0. 1, 1, 2, 4, 3. Substitute 3 there, you also get what? 9. So I'm going to draw now this graph. I'm now coming to draw. I will say okay, there you go. There you go. Okay. This is the y-axis. This is the x-axis. On the x-axis, I've got negative 3, negative 2, negative 1, 1, 2, then 3. Going up, I'm going to use 2, 4, 6, 8, then 10. Okay, now that's those are my units. The first one is negative 3 and 9. Negative 3, 9. That's your point. That's your coordinate. Negative 2 and 4. Negative 2, 4. There you go. Then negative 1 and 1. There you go. 0 and 0. 1 and 1. 2, 4. Then 3, 9. There you go. You join this with a free hand, with a curve. You come up with the graph of f drawn. So this is the graph of f of x, which is equal to x squared. Okay, right. I'll go back now to the same table. I'm now filling it in, but I'm now considering that um, I'm now trying to draw the graph of g of x, right? My g of x, if you look at g, I'm now substituting. If you substitute a g, you realize that it's now negative 3 substituted where x squared is. Negative 3 squared is what? 9 plus 1, that will give you 10. Negative 2 all squared is 4 plus 1, that will give you 5. Negative, uh, negative negative 1 squared plus 1, that will give you 2. 0 squared plus 1, that will give you 1. 1 squared plus 1, it will give you 2. Then 2 squared plus that will give you 4 plus 1, it gives you 5. That will give you what? 10. Okay, right. That is my table of value. I'll also come to my sketch, negative 3, negative 3, and 10. There you go. Negative 2 and 5, you can see, right? Negative 1 and 2, you can all see that. Negative 0 and 1, it will go there, then 2, then 5, then 10. Good. If I'll draw this, you'll see that this is now the graph of g of x. So your g of x is equal to x squared plus a 1. Now, if you compare the two graphs, that's where the generalization comes into effect. Right? If you look at these two graphs, f of x and g of x, what is the difference between these two graphs? Graphically, you can see that f of x is like it was pushed 1 unit up. F of x was moved 1 unit upwards. So when I go to a function and say plus 1, it means that function is going to go 1 unit upwards. Compare them functionally. Functionally, f of x was x squared. G of x was x squared, is now x squared plus 1. So when I go to f of x and say plus 1, the graph is going to shift 1 unit upwards. So when you are given any function and they say shift it 1 unit up, it's just going to that particular function and you say plus 1. As long as you are adding a constant, the graph will go up. If you want to shift a graph 2 units up, you just come and say plus 2. The graph will go 2 units upwards. If you want it 5 units up, you just go to x squared and say plus 5. It will go 5 units upwards. So as long as you're adding a constant to any function, be it a trigonometric function, be it a logarithmic function, and if you want to push it 3 units upwards, if you want to shift it 3 units up, you just go to that exponential function or logarithmic function or trig function, you say plus 3, the function will definitely go up. Okay, let's look at h. Let's look at h. The same thing happens with h. If you look at your h of x, let's try to complete the table so that we can make the same generalization. Okay, but I'm sure we are following whatever we did with g of x is the same thing that we are going to come up with h of x. But just for simplicity and clarification, let's look at this. Negative 3 all squared, you get positive minus 1, you get 8. Negative 2 squared is 4 minus 1, you get 3. Negative 1 squared is 1 minus that minus 1, it becomes a 0. 0 squared minus 1, it becomes minus 1. 1 squared minus 1 is a 0. Then 2 squared minus 1, 2 squared minus, it's a 3. Then 3 squared minus 1 is 8. I'm now sketching. That will be 8. That's where my 8 is. Then that will be 3. That's where our 3 is. Then 0, negative 1 is 0. Then minus 1. Then 0. Then 2 and 3. Then 3 and 8. If I join this, I'll get something of this sort. If you look at this is now your h of x, which is what? X squared minus 1. What did I do? Q is minus 1. When I subtract 1, f of x went 1 unit down. If you look at and compare this graph to the graph of f of x, you realize that the graph of x was shifted 1 unit downwards. Okay, right. So that is very, very, very important. Very important. Let me make a conclusion there. Let me make a conclusion. Then I'll give you an illustration. Right. Let's look at this conclusion. Right. If Q is positive, meaning to say Q is greater than a 0, the graph shifts what? Q units upwards. Right. If Q is negative, if your Q is negative, meaning to say Q is less than 0, then the graph shifts Q units downwards. Okay, right. That is very, very important. Now I'm going to look at the basic examples that I'm going to be doing, and I'm going to be applying this notion. Remember, this is a notion which is coming from your grade, your grade, your grade 10. Okay, let's look at an example to this example. Very simple example. Given that f of x is equal to 2 all over x minus 1 plus 1. Shift f of x 3 units upwards and write the resultant function as g of x. Okay, now look at this. What am I saying? F of x is shifted 3 units upwards. Write the resultant function as g of x. What I know is I don't have a function, I don't have a graph in this case. I am given a function. But what I know is as long as I'm adding 3 units, the graph is going to what? The graph is going to go 3 units upwards. So functionally, it is the same thing that is going to happen. My resultant function is g of x. So I'm going to say g of x is the result of f of x. But what happened to f of x? Since it's going to be moved 3 units upwards, I'm going to add 3. Just like what we did with our illustration. When we wanted x squared to go upwards, we added. When we wanted f of x to go downwards, we subtracted. So this is the same thing. We want f of x to go 3 units up. So I'm going to go to f of x and say plus 3 to come up with the resulting function, which is called g of x. So where there is f of x, I am now coming to say this is 2 all over x minus 1 plus 1. That was f of x plus 3, which is being added. So the resulting function g of x is x minus a 1 plus a 4. That would be the transformed function. Okay, right. Let's look at the second example on this. Example 2 on this. Right. On my example number 2, I'm simply going to say given that f of x is equal to log x base 2 and g of x is equal to sine x, something like this. Let me just say sine x plus 30 in brackets, something like that. Then the question says shift a, shift f of x 3 units downwards. Right. Now shift f of x 3 units downwards. Since I'm not given the resulting function in this case, I'll just come and say f of x is going to be equal to f of x minus 3 units because you want it to go down. So this is going to be equal to what? What was f of x? It is log x base of a 2 minus a 3. That would be the transformed function. B, shift g of x 1 unit upwards. Right. So it means since I don't have a resultant function, g of x is equal to what? G of x plus a 1 because you want it to go upwards. So you go to your function which is sine x plus 30, then you just come and say plus 1. As simple as that. You shifted this graph 1 unit downward. Okay, right. That is transforming. I only looked at one parameter, which is the shifting of functions, either up or downwards. Okay, right. That is how you shift a function either up or down. So any function, be it an exponential, be it a logarithm, be it any function that you think of, if you want to shift it vertically up or vertically down, it's a matter of just going to add or subtract number of units to the given function. Okay, right. So I'm going to stop there for now, and I'm going to look at shifting functions either to the left or to the right in the next class. Thank you for joining us. Keep following us, and let's complete this section together. I hope and pray you've picked one or two things from what we've discussed, but this is how you transform a function, shifting it either up or down. Okay, thank you so much. Let's meet in the next class.